Hello everyone, I am Mr. Shukdev Shah from ECA department and from Regent Education and Research Foundation. Today I am going to deliver a lecture on a topic of digital electronics. The topic is simplification of Boolean expression using Carnot map. The content of the slides or PPT is introduction. What are the advantages of Carnot map? What is SOP and POS, simplification process of Carnot maps, different type of Carnot maps, simplification logic by Carnot map, don't care condition, and how to design a conventional circuit. First, the introductory part. Carnot map is first invented by Maurice Carnot. From the name of the scientist or inventor Maurice Carnot, it came that Carnot map. In the year of 1953, he had invented this mapping process, and it is usually known as K-map. For our daily, when we are frequently call the mapping system, it is usually known as K-map. It is basically a graphical way of representation of Boolean functions, and it is used to minimize the Boolean function. How we can minimize the function and simplify the function. There is other way that we can minimize, that is Boolean algebra, but it is sometimes difficult to minimize the things. But Carnot map is a simple method or simple mapping method through which we can minimize the logical expression, bigger logical expression, to a simplified form. It consists of tables of rows and columns with entities 0 and 1. That means the cells of the table or mapping system only contains 0 and 1. The K-map can be used for expression starting from variable 2 up to 6. In general, we are doing this for 2, 3, and 4. For up to 4, it is randomly used, but it may be possible up to 6 variables. What are the advantages of K-map? Why we use K-map? Alternative to other methods, why it is superior, why it is friendly? Because it is very much simple of minimization of Boolean expression, and the changes in neighboring variables are easily displayed. So we can say that is reduces the cost and quantity of the logical gates. It is best. And why it is effective? Because when we simplify a expression, then obviously the number of gates will be reduced and the costing will be reduced. So obviously we can use Carnot map to simplify the logics. Now, what is SOP and what is POS? SOP, the full form of SOP is sum of product, and it represents 1. SOP, for such, here there is a example of SOP. SOP such that A dot B plus B dot C. That means there is a product A dot B and there is a product B dot C, and the product is sum to each other. Next one, the product of sum, that is POS. Expressions represents 0, and the example of POS, we here can see the example A plus B dot C plus D. That is, it is a sum, and C plus D also a sum. Two sums are product to each other. So this is the basic concept, which is SOP and which is POS. Now the process, in very brief way, the simplification process, how K-map works. That is, the process is no diagonal cells can be form a group. that is first one, no diagonal cells cannot be form a group. Second one, that is only 2 to the power n cells in a group. So in a group 2 to the power n, that means when n is equal to 1, that means 2 to the power 1, that is 2. When n is equal to 2, it is 4. When n is equal to 3, it is 8. When it is 4, it is 16. So the group, elements of the group may be 2, maybe 4, maybe 8, or maximum it will be 16. So we try here. Next one, the groups should be as large as possible. That is that the meaning of this line, that the group should be larger, because when it may form 8 elements in a group, it should be 8, not it will be divided into 4 and 4. So we are always trying to group maximum number of entities or cells in a group. Next one, that is overlapping allowed. That is the important feature. The overlapping between two groups is allowed, but when there is no uncovered entities, there should be any groups. Fewest number of groups possible. So fewest number of groups possible, that means we always try to make group to a minimum number, because if we do not consider the minimum number, the expression will be bigger. So here we have the motto to minimize the logical expression. So if we do the fewest number of groups, at that time only it will be possible. So we are starting from two variable map. Here we discuss two variable map, three variable map, and four variable map. So here we first start with two variable map. Here, this is the structure of mapping system. These two are the same. Here first there is two variable x1 and x2. So here x1 have 0 and 1. One variable may be only two types. In digital electronics, only it may be 0, it may be 1, it may be high or it may be low. So it is x is equal to 0, x is equal to 1. For x2 it is 0 or 1. So for this cell, the decimal value 0 0. So x1 x2, that is 0 0, that means this cell is 0. 0 1 means 1, 1 0 means 2, and 1 1, that is 3. Okay, the same here, that is x1 is the upper one and x2 is this one, lower one. So x1 0 1, x2 0 1. So here we have to consider from this side 0 0, that means 0, 1 0, that means 2, 0 1 is 1, and 1 1 is 3. So this is the basic structure of the two variable map. Now we are going to the three variable Carnot map. So three variable means 2 to the power n will be number of cell. That means here 2 to the power n means here 2 to the power 3, that is 8 cells. Here 8 cells, 1 2 3 4 5 6 and 7 8. So here we are mapping in this format, that is AB is lower portion and C is upper portion. So here we have row wise AB value row wise, that is 0 0 0 1 1 1 1 0, and C is equal to 0 and 1. So here considering from this side, that is AB 0 0 and C ABC, that is 0 0 0, that means ABC, that is 0 0 0 means 0. It is decimal value for this cell is 0. Here we considering A complement, B complement, C complement, C A bar, B bar, C bar. Why it is bar? Because A is equal to 0, B is equal to 0, C is equal to 0. When in case of SOP, we are considering A equal to 1 and A bar equal to 0. Okay, then 0 0 1, that means A0, B0 and C1, that is A bar, B bar and C. 0 0 1, that is A bar, B, C bar. Likewise, all the cells are be filled. So here the 4 variable K-map, that is the most important variable which is in real life we have in digital electronics mostly used. So here 4 variable K-map. So this is the structure of 4 variable K-map. That is in the lower side we have written, that is AB, and upper side CD. So AB is 0 0 0 1 1 1 1 0. CD 0 0 0 1 1 1 and 1 0. So here the number of cells obviously in the formula of 2 to the power n, that means 2 to the power 4 here, n equal to number of variable, that is 16. So 0 0 0 0 0, that means is equal to 0. 0 0 0 1, that is the decimal number is 1. 0 0 1 0 is 0 0 1 1, it is 3. 0 0 1 0, it is 2. So likewise all the cells will be turned, that is 0 to up to 15, that means there is 16 number of cells. And here also the logical expressions are written here. K-map of SOP minimization. So here first of all we doing SOP because it is mostly used sum of product. So it is generally to minimize the expression can be implemented with fewer logic gates than a standard expression. We have a standard expression that is unsimplified or not minimized. So we, with the help of the K-map, that SOP expression will be converted into a simplified version or minimized version. Now we are going to the rules of the grouping. How we can group, that is the most important thing. Say there are few rules. Some boxes are drawn here, that is wrong, some are right. So here first one, that is wrong. How why it is wrong? Because there is grouping of 1 and 0, that is not possible. When we grouping in case of SOP, that is we group only once, adjacent ones. Okay, so that is 1 0 is totally a wrong grouping. So we do not follow this. We follow that is adjacent two ones in a adjacent place. So we group these two, and that is the important thing, that is diagonally there is 2 1, but diagonal grouping is not right, it is wrong one. And here this is right, there is this 2 1 is in group and this 2 1 is group. That is one important thing, that this one is overlapped, but here we already said that grouping of overlapping is allowed. Next one, that is element in a group should be 2 to the power n. Element 2 to the power n means it will be 2, it will be 4, it will be 8, it will be maybe 60. So it is right one, that is group of 2, this one. But when we group 3 ones in a adjacent place, that will be wrong. This is right obviously, because there is 4 ones in adjacent place, we may group this one. And here this is wrong because we consider here 1 and 0 simultaneously, that is totally wrong. It will never be happen when 1 and 0 in a same group. So next rules, that is minimum group should be done. Here look at these two K-map, that is here these 4 in a group and these 4 in a group. Okay, so these 4 and these 4, that means there is 2 groups. But if we do this with this one, and this one, there is 3 group. So obviously two rules is violated. One is maximum number of elements is not included in a group. Here should be 4 in a group, but here we do only 2, only 2, only 2. So there is 2 violation of rules. One is maximum element not in the same group. Another is minimum number of group is not maintained. Here 3 number of groups, here only 2 number of groups. So this one is right, this one is wrong. And here this same function, that is group overlapping, there is group overlapping is allowed. Earlier I am saying that is group overlapping has no problem. Next one rules, that is leftmost cell, that is this is the leftmost cell, this is the rightmost cell, looks as a adjacent cell. It may be, we can seen as a adjacent cell, and these 2 may be in a group, this one and these 2, that is 4 elements in a group. And topmost cell and bottommost cell will also be in same group. Next one. Now from the expression, how we can draw the K-map. So suppose there is the expression a bar b bar c plus a bar b bar c plus a b c bar plus a b bar c bar. So this may be into binary form. A bar b bar c bar means 0 0 0. A bar b bar c means 0 0 1. This is 1 1 0 1 0 0. So this is the Carnot map, standard Carnot map format, A B C. So 0 0 0 means this one is 1 for SOP. This one is 1. 0 0 1, that means this one is 1. 1 1 0 1 1 0, that means this cell is 1. 1 0 0, that means this cell is 1. That is the way how we mapping a standard SOP expression into a K-map. Now determining the minimum SOP expression from a Carnot map. So here we consider that this is A B C D, this is A B, this is C D, and here already K map is done. Here we are doing, that is 4 ones in a group, 8 ones in a group, and there is 2 1 in a group. That means there is 3 groups. That is, now how we can get the simplified version from these groups. So now we have to extract the logical expression from the groups. How we can do this? That is, first we are doing from this one. Consider the red one, red group. So from red group we can see that the corresponding value to the group, red group, that is corresponding value AB 0 1 and 1 1. So we have to look at this one, that is which value is here constant and which value is varying. So from here we can say that A is varying and B is constant. Okay, and from here for this group all the 4 others are varying from the upper side. Here 0 0 0 1 1 1 1 0, all are varying. Only here the fixed one is B. That means the rules is we have to took only the fixed one. Which are the varying one we cannot take, it will be deleted. So here we consider only B. So the logical expression from this group is B, right? So the next one, that is this violet one, that is 0 0 0 1. 0 0 means here A is constant, B is varying 0 to 1, and here the corresponding value of CD is 1 1 1 0. So here the constant one is C, that is here a value of a is 0, that means a bar, this is a bar, and c is 1, that means c, a bar c, right? The last one, that is this one covering only two ones. So here the corresponding value of AB 1110. The 1 is constant here and B is varying. So here also this is only one column, that is 0 1, that means C bar D. So from this one we can write A C bar D. So as a whole, the simplified version of this of this K map is B plus A bar C plus A C bar D. Next slide. Okay, these are the some examples of three variable K maps. So here very easy examples. So here f equal to summation 0 4. 0 4 means 0 and 4 have the value 1. So these are the 0 and 4 have the output 0 and 4, 1 1. 0 0 0 means 1, 1 0 0 is 1, others are 0. So we grouping this one. So from here we can say B bar C bar, B bar C bar. Next one, here the same 4 and 5. This cell is 4, this cell is 5. So we cover this one. So grouping is this one. So A, and here constant is term is B bar. B is constant, that is 0. So A B bar. Next, here A is varying and here 0 is constant, that is 0 B bar. This way, this is the, and here this one, take this example. So here we can say these two, that is the leftmost and rightmost. So we can form a group of 4 elements, that is here A is varying, and consider this one and this one, that is which term is constant, that is C. C is value of C is 0, so we may read written as C bar. And the others are the simple manners. A here same things. This is 1 and 1. So we from the leftmost we take this one, rightmost take this one. These two forms the group. Next, example of 4 variable K maps. So here 4 variable K maps means we know the format, that is 16 cells from 0 to 15 are there. A, B and C, D is the variables. So here we put here only 2 are inputs are here, 0 and 8. 0 0 in the position of 0 we put the 1, and 8 we put 1. So only these two are 1, others are 0. So from here this is the uppermost and this is the lowermost. So these two forms the grouping. So from here we can write the logical expression, what that is here 0 0 1 0. So here 0 is constant, that means we may write B bar, and from for this column 0 0, that means C bar D bar. So that is B bar dot C bar dot D bar. This way take this example, this one for this uppermost and lowermost also group form the group, and the B bars is the corresponding logical expression. Here also this, consider this one, here B from A B 0 0 0 1. A is 0, which is constant, so A bar, and this is C is constant, that is 1, A bar C. Here also we consider that is top corner of 4 corners of the K map may be grouped, and we can derive the logical expression. Now how we can mapping directly from a truth table to a K map. So this is a truth table given to us, that is A B C. So how we can write a truth table, that is truth table for 3 variable. It is from 0 to 7. That means 8 8 options there. So 000, 001, 010, 011, 100, 101, 110, and 111. That means we may see that 000 means 0, 001, 1, 010, that is 2, 011, that is 3, 4, 5, 6, 7. So we consider from 0 to 7. Now here that is output is 1, output is x is equal to 1 in case of 0, in case of here 4, in case of 6, and in case of 7. So 1 is 000, that is putting this position, this one putting this position, this one is 110, that is this position, 111 this position. So it is the mapping directly from truth table to K-map. Now the another important thing which will which will change the concept of K-map without the application of don't care, we cannot complete the K-map. That is, what is don't care? That is, don't care means that is it may be marked as a cross. There is cross, and it may be marked with small d. Okay, so don't care means it may be 0, it may be 1 according to the grouping. According to the grouping of the K-map, we may be considered as a 1, it may be considered as a 0. That is the benefit of the don't care. When it is necessary to group, then we consider don't care as a 1. The benefit of that we may complete the grouping, we may minimize the term, minimize the final expression. That is the benefit of don't care, that is the use of don't care. So here we set a example of K-map using don't care. So Boolean expression, if these 4 are the variables a, b, c, d, this is the 1, 3, 7, 11, 15, and don't care values are 0 to 5. Now put the values here, putting the ones, 1, 1, this position 1, this position 1, this position 1, and this position. There is 6 values, 1, 2, 3, 4, 5, and 6. So here sorry, 6 not, there is 5 values. So 1, 2, 3, 4, and 5. There is also 5 values. And 3 don't care. 0, that is 0, 0, 0, 0. This is D. 2, this is 2 position. 2 position D is here, and this D is here. So here we can look at this. There is 4 ones in a adjacent position, so we may group this one, that is 1, 1, that is C, D, right? This A, B is changing, so we consider only 1, 1, that is C, D, this one. And for this one we include the don't care. If we do not include the don't care, we cannot group with these 4 elements. We can group with these 2 only. So with the help of don't care, we can minimize the term. So here these 4 are changing or not constant. Only A and B, the value of 0, 0 is constant. That means A bar, B bar. So we can write the final expression as A bar, B bar plus CD. So mapping a standard POS. Till now we are discussing about the SOP. So SOP is, we are considering A is equal to 1, A bar equal to 0. The whole thing here just opposite of SOP. POS is the just opposite of SOP. So here 0, 0, 0, that means here considering 0 means A. Here 0, 0, A plus B plus C, that means A corresponding POS is 0, B for 0, C 0, A0 B bar 1 C 0, A bar plus B bar plus C, that means 1 1 0, A bar plus B plus C bar, that means 1 0 1. Now we are putting the values in the K map. So here obviously we put 0 instead of 1. In case of POS we put 0. So 0 0 0, this is 0, 0 1 0, this is 0, 1 1 0 0, 1 0 1, 1 0 1, that means this cell. So 0 0 0 and 0. So that's how we can mapping the POS expression in a K map. POS expression, there is just opposite of SOP. Here we consider the 0 for the values. Now K-map simplification of POS expression. So here POS expression, here we consider this POS expression as like the SOP. Here 4 zeros in adjacent position we may group. So here we can consider 4 groups as a B. So here we can consider that is from this A is there, others are changing. And next one, this group, that is this group will give us A bar plus C. This is the expression from the POS. Now design of conventional digital circuit. How we can design a conventional digital circuit after doing the simplification. So from the problem statement drive the truth table. So first of all we have to do the a logical expression to a truth table, then truth table drive into the unsimplified, that is the truth table of unsimplified logical expression. Simplify the logical expression with the help of KML. We can simplify it, then after simplification it will be minimized, then the minimized version may be converted into the conventional digital circuit. Okay, so this is the example how to design a conventional digital circuit from Boolean expression. This is the Boolean expression. So here this one, and from this expression we can put the values here. After getting the values, putting the values, we get the simplified version A bar B bar C bar D plus A C bar D bar plus A C bar D bar plus A B D. So these one are the 1 2 3 4. 4 are the so this is obviously grouping. 4 grouping are here. So this is SOP. So from here, from this expression, we get this expression from this one, from this truth table, from this K-map, from this K-map. So after simplification, we can draw the digital conventional circuit. So 4 variable, one A, B, C, D. So we connect 4 NOT gates to getting the bars A bar, B bar, C bar and D bar. So for this just connect for product, connect AND gate, and this is NOT gate for some part. So here A bar and B bar, this one for A bar B bar, for A bar B bar we connect A bar B bar, A bar B bar, and this is C bar D bar. So A bar B bar C bar D, so all are connected to a final AND gate. Here also B C bar we connect it to the B line and C bar to the NOT gate line, B C bar, and there is only D bar, B C bar D. This wise we can finally get the Y, that is the value A bar B bar C bar D plus B C bar D bar plus A C bar D bar plus A B D. So this one the final one. So from my end, this is the all about the Carnot map. So I hope all of you may understand through this video lecture, and in future I am trying to deliver other lecture, other this kind of lecture on the various part of digital electronics. Thank you all. Thank you very much.